I probably need batteries. Hey, looky there, there we are. Now it depends on where you look, which trig function you see. So I'm going to highlight the interval, say, from 0 to pi halves. If we just look on the interval from 0 to pi halves, what do you see? Sine or cosine? 0 to pi halves? Just looking there, that's an upside down cosine, isn't it? So how do we make the graph upside down? Where? Which letter? A. If A is positive, it's right side up. If A is negative, it's upside down. So that number A was the amplitude. And typically the amplitude is max minus min divided by 2. And if A is negative, then you flip it. What does the number B do to the graph?
It makes it wider.
Okay, it affects what I call the period. Now they're using different nomenclature on WebWork, so be careful with some of them. They're calling the minus B over C the horizontal shift, and I'm calling it the phase shift. They're just going to call this last number the phase shift. But at minus B over C is what I'm calling the phase shift, and what everybody and his dog calls a phase shift. Talk to your dog, he'll tell you. But it affects things going left or right. Typically, the sine and cosine have a period of 2 pi. The number B by itself, I wrote that upside down. Did I say minus B over C? Not minus C over B. Minus C over B is the phase shift, where B changes the period. The number 2 pi divided by B is going to be the length of the period. That's the length that it takes one cycle of the sine or cosine. And then what does the number D do out on the end? Moves the whole graph up or down. So that one's going to be called a horizontal shift.
Vertical.
Other way, right? Vertical shift. I pointed. Up and down shift. I didn't know mastery of the English language was important in this job. I just thought I could put my head down and do math. Can I just turn my back and just do math and you guys write what I write, and then we don't have to talk and I don't have to look at you and stuff like that? Okay, now let's work from there back to there. So I've highlighted an upside down cosine curve in that interval. And how long is that interval? Pi over 2. So we've got to figure out B from that. We've already seen that A has to be negative. A negative what?
2.
A negative 2. Because my tallest point is a 2, my lowest point is a negative 2. That distance is 4. Cut it in half, and you get A is 2. Flip it over, makes A negative 2. Okay, so we can see A is negative 2 here. This one shows a period of 1 cycle, completes in an interval of length pi over 2. So we're going to solve this equation for B. So what's B? Multiply by 2, divide by pi, what do you get? 4. B is 4, right? Here's what you get when you multiply by, cross multiply by 2, multiply by B, divide by pi. Who brought their phone to class? No way. It's important. Maybe somebody wants to tell me my vehicle warranty is expired and I can get a new one.
Oh, no.
So B is 4. All right. Has this been shifted left or right? Well, no, because this point here is typically when X is 0 and Y is 1. We just flipped it upside down. So it still begins and ends its period 0. So there is no phase shift. Which makes our C 0, and nor has it been picked up and moved. So that makes D 0. So we've got our A and B, and the other values are 0. And so we should be able to write this as f of x is -2 cosine of 4x. Yes, sir.
How do we know that there's no phase shift?
Because I've got my period starting here. I'll do one next with a phase shift using that same graph. Which is the second one. The second one, I have the same graph, I kind of expanded it over a bigger interval. And I'm just going to color a different interval on here. If you look at that second example that I have for you, it's the exact same thing. I just graphed it in a bigger viewing window. But this time I'm going to look at the interval from pi over 8 to 5 pi over 8. So let's consider only the part of this graph from pi over 8, for our second example, from pi over 8 to 5 pi over 8. And tell me what you see. That's this one, right? So I'm going to be able to write the sine curve and notice that it's shifted away from the origin. So this one does have a shift vertically, right? There is a vertical shift. Gosh, dang it. I almost said the other word. Horizontal shift. There is a horizontal shift of pi over 8 of the sine curve. Have I changed the length of the period? How long is the interval from 5 pi over 8 to pi over 8? Pi halves.
Yeah.
That's the same as the period was before, right? So I haven't changed the period. All I've changed now is the trig function with the phase shift. Amplitude's the same, D is still 0. And it's not going to have a negative amplitude because it's a right side up sine curve. So for the second example, we're going to use this. We don't have a D, we will have a C. A is 2. Our period is still 5, 3, when I said that number was 5 pi over 8 minus pi over 8 is 4 pi over 8, or still pi halves. So we have the same B as before. But now we have a shift that way. Of pi over 8, which means minus C over B has to give us pi over 8. We said b was 4. So we're going to take this equation and solve it for c. And you shouldn't be surprised that it's pi over 2. Didn't I just say that sine and cosine take on the same values, but pi over 2 units away from each other? So if I just shift that graph that I highlighted in the first example to the right, pi over 2, I've got this graph. And so this function, shaded in red, would look like f of x is positive 2 sine of 4x minus pi halves. Okay? So it just depends on where you look. If we look, say, from pi fourths to 3 pi fourths, we've got a shifted cosine function, right? So what I'll try to do is just give you one period and have you write it from there. But I just want to emphasize there's several ways I could do this.
Yeah, I was confused because I was wondering why we started here instead of from the origin like the last one. But
Because I'm showing you, when you shift a little bit, you'll get the other graph. So had I extended this graph back here a little bit, you'd have gotten a right side up cosine function to match that one. Okay. It is hot in here. Let's write the third one now. So the third one is just one period. Let me draw it up here. Make sure I'm recording. Drag. Okay, so this one goes from an interval from 0 to 2. Here is 1.5. So here is 2. This then would be 1, and this is 0.5. And this is 1.5. This down here is a negative 1.5. So it's got this shape. Our choice then is to write a cosine function for this. I don't need a D because it's balanced around the horizontal axis. So I haven't done any lifting of the graph up or down. It's right side up, so A is positive. What value is A? 1.5. A is 1.5. How long is the period? 2. So 2 pi divided by B has to simplify to 2. What does B have to be? B is pi. Get that pi to cancel. So I'm going to put a pi right here. What are your thoughts about C? It's not, we don't have any shift in either direction. It starts where the cosine would normally start at 0 y-intercept. And then so C is going to be 0. So that's it right there. Okay. All right, now let's look at the next one. The next one is graphed all the way out to 8 pi. So that's the notches are at pi, 2 pi, 3 pi, 4 pi, blah, blah, blah. It just got kind of smushed together when I changed the scale. So it goes on out to 8 pi to complete one cycle that looks like an upside down cosine, doesn't it? Starts at 0, 0, makes a mound, comes back, and I've terminated the graph at 8 pi. The peak occurs at 4 pi, and then here's at 0. And then at 4 pi, it hits a height of 2. So why is it going through 0, 0? It's been shifted up, hasn't it? It's a upside down cosine that's been shifted up. If I stretch this back down here, cut that in half and that in half, and draw you an upside down cosine, it's a shift of this graph up 1 unit, right? So we do have a value of D. D is going to be positive 1. Can you tell what A is going to be? Negative 1. Take the max minus the min and divide by 2. The max is 2, the min is 0. 2 minus 0 divided by 2 gives us 1, right? Because if I put it down here, then that's 1 unit up and 1 unit down. So A is going to be negative 1. Where am I doing my writing? Let me erase this. A is going to be negative 1. D is going to be a positive 1. Take that upside down graph and move it up. Now this has a period of 8 pi. So 2 pi over B has to equal 8 pi. Solve that for B. B would be 1/4. If I multiply by B and then divide by 8 pi. So B is 1/4. When your period gets stretched out that way, then B is going to be smaller than 1. All right, has there been a phase shift? No, I've got it centered at the midpoint and starting at 0. So that means C is going to be 0. So if we fill all that in, then this graph should look like f of x is equal to minus 1 cosine of 1/4 x, no phase shift, plus 1. And if you see it written with the 1 in the front, that shouldn't make you all worried. It just looks nicer when you put it in this order, right? Yes.
So when we're finding what B is, why do we put 2 pi on top?
The regular period is 2 pi, and B is a scale factor. So we take 2 pi and scale it by B, and that's why we do that. Yes.
Do we need the 1 in front of the minus cosine? Or is it just the-
Yeah, it's the same as putting a 1 here. Right? Doesn't it look goofy when I write the 1?
So we could, do we need the 1 in front of the very front, like the 1 minus?
Yeah, because that's this one.
Okay.
I just rewrote it so that that was the lead term. So that you wouldn't lose the minus sign. Okay, so I had another one that's not on here. Let me draw it for you. And then you tell me what I've got looking at you. So draw this on the back somewhere. pi. That's half. Let me do some scribbling here. Just scribbling, I'll do a better example. Oh, well. Where did you go, ink? At -1, -2, -3. Yes. That's not what I wanted. All right, so these are fourths here. Those are pi halves. So I want this to go like this. Go. Oops, I want this here. What is here? Here. Okay, I wanted to cross at -pi4, +pi halves, and then this one would be at 5pi4. And I want it to do, let's see. Here. Here. So this is going to be, say, at pi8, -3. And this is halfway between, what would this be? 3pi4 and pi. So what's that pi8 between 3pi4 and pi?
7 pi 4.
7pi8. All right, so your graph is going to look like this. So at 7pi8 here, it's hitting that one, and then at pi8 here, it's hitting -1. It has an intercept at -pi/4, and at 5pi/4, and at pi halves. Let's see if I drew this right. Let's try to write something about this. Which trig function you want to use here?
Sine.
Let's use a sine. What do you know about A?
-3.
A is a -3. A is the stretching this way. It's upside down sine curve. And the tallest point is 3, the lowest point is -3. So we're going to use a sine curve with A is -3. Okay, how long is that period right there? I've got it ending at,
3 pi over 2.
begins at pi over, negative pi over 4 and ends at 5 pi over 4. And so the length of that is 6 pi over 4, which is 3 pi over 2. I labeled that rightly. I think I did. Yep, that's 6 pi over 4. So that's the length of the period. So we need 2 pi over b to simplify to 3 pi over 4. Let's solve for b. We need 2 pi over b to simplify to 3 pi over 2. So let's cross multiply. 2 times 2 pi gives me 4 pi. B times 3 pi over here. Divide both sides by 3 pi. And so B simplifies to 4/3. Okay. Now, is there going to be a value of C in this example? Because there has been a phase shift. It's been shifted to the left pi over 4 units. So we've got a shift of pi over 4 units. So we need minus pi over 4 to equal minus C over B. B we found to be 4/3. Cancel the two negatives. So you have pi over 4 is minus C divided by 4/3. Let's multiply both sides by 4/3. Fours will cancel. Move the minus sign to the other side. C is pi/3. Hasn't been picked up this way, so D is going to be 0. So let's put our numbers into our equation. I've got the A, B, and C. So we have that f of x is equal to -3 sine 4/3 x minus pi/3. Okay. You like that one better? All right, now I'm going to try giving the description in words and see if you can write the equation of the trig function. Maybe. There's my glasses. There's my description in words. Find an equation of a cosine wave, cosine function that is obtained by shifting the graph of y is equal to the cosine of x to the right pi and downward 3 units and vertically stretched vertically, that's up and down, by a factor of 2 when compared to cosine of x. Okay, so first I'm going to do it without this. I'm going to draw the picture without this. It's a cosine curve moved to the right pi unit. So here's a cosine curve. Moved to the right pi unit. So I'm going to move it away from 1. And I'm going to keep it centered here right now. So move to the right pi units. And vertically stretched by a factor of 2. So I'm going to move that up to 2 and this to -2. So there's that. We don't have any stretching this way. So that means the period has not been changed. So I need to go 2 pi out this way. So that puts me out here at 3 pi. And then that one's 2 pi right here. That's without this. Now I'm going to take it and move it downward 3 units. I'm going to draw that in red. So it's going to take this point here and go 1, 2, 3. It's going to take this point 1, 2, 3, and this one 1, 2, 3. So we're going to write the equation of this red function here. But I drew the first one so you could tell me what A is. What is it? What are you going to use for A?
2.
2. I'm using a cosine. So A is 2. We haven't changed the period, so C is 0. This one's the next easy one to get. B is going to be -3. And now we have to figure out what B is so that that shifts. Oops, B is 1, never mind. C is not 0, B is 1, because I keep the period the same length. C we're going to find now. The period has been shifted to the right pi. So I have minus C over B has to be pi, but B is 1. So C is minus pi. And then I think we're done. Our equation should be f of x is 2 cosine x minus pi minus 3. Is that okay with you? Well, there's one on your web work to kind of do with words to see if you can write the equation. All good? Then I want to do the next two sections together. We're going to look at the graphs of the other four trig functions. Tangent, cotangent, secant, cosecant. And I brought you some graph paper. It's printed front and back. I don't know how many you're gonna need. On your row. Two of them. If that's what's down to these. Some more. That could be 8 examples. We've got 4 trig functions, and then we'll do a variance of them. Yeah. Bring it back without tripping over the cord of the chair. So in sections 4.3 and 4.4, task is to graph tangent of x, cotangent of x, secant of x, cosecant of x, and then see what their periods are and how these numbers affect them. So let's look at graphing tangent of x. This is sections 4.3 and 4.4. So first, let's look at graphing f of x is equal to the tangent of x. But the tangent of x is defined in terms of the sine and the cosine. It's a rational function, which means we run into trouble anytime the denominator of a fraction is 0. And there are several places that make cosine of x 0. There's no value of this number on the right-hand side. The tangent's not going to be defined at all the places at which the cosine is 0. So this is not defined where cosine of x is equal to 0. And where's that? Where's the cosine 0? Okay, 90 degrees is pi halves radians. And then again at 3 pi halves, 5 pi halves, any of the odd multiple of pi halves. Here's the way we write that. Instead of making a list of them, it's not defined when x is odd multiples of pi halves. So if n is one of our counting numbers, you double the counting number, it's even. go right next door and you find an odd number. So if I take 2n plus 1 and multiply it by pi halves, and then I can say that the domain of this trig function is x's other than odd multiples of pi halves. What do these places look like on the graph? If you're graphing a rational function and the denominator is 0, what does that look like graphically? Look at, say, 1 over x plus 2. When x is negative 2, I don't have a y value. Are you aware of vertical asymptotes? All of these lines are vertical asymptotes. Now, our sine and cosine functions themselves never exceed a value of 1 or negative 1 because they represent points that are on the diameter of the unit circle, whose radius is 1, hence the name unit circle. All right, tangent's not a point on the unit circle. Tangent's the slope of the line that goes through those points. So tangent can take on values that are 0, positive, negative. There are even places where the slope of the line is vertical, or vertical this way. Since the tangent is the slope of the angle, or the slope of the line through the ordered pair that gives you the sine and cosine, the tangent can take on any real number between minus infinity and plus infinity. So that's the range of the tangent function. Now I'm going to put my grid up here. All right, so we're going to pi, 2 pi, negative pi, negative 2 pi. Let's put the halves in here. And at each pi half, I've got a vertical asymptote. There's no graph there. Now, the next thing to observe is that this thing has intercepts on the x-axis whenever the sine is 0. The tangent is 0 wherever the sine is 0. And where is the sine going to be 0? 0, pi, 2 pi, blah, blah, blah. Any multiple of pi. X is equal to any counting multiple of pi. Right? So when I'm using the number n, it's just a counting number. Heck, it's even 0. Plus or minus. So I guess we can call those the integers, huh? So the tangent graph is going to cut through the x-axis at those places. Now let's look at the graph in here. This was at pi halves, or negative pi halves, and this is at pi halves. Let's look at the value of the tangent at pi over 4. What is the tangent of pi over 4? It's 1. So tangent of pi over 4 is right here, is 1. What's the tangent of negative pi over 4? It's negative 1. Pi over 4, negative pi over 4, if you think on the unit circle, is in the 4th quadrant. Cosine's positive, sine is negative, but both are square root of 2 over 2. So back here, we're down to negative 1. So this was at pi over 4. Can you name an angle between pi over 4 and pi over 2 that you would know the value of the tangent of? Pi over 6 would be in here. So let's go bigger. Pi over 3. What is the tangent of pi over 3? Sine of pi over 3 divided by the cosine pi over 3. Come on, at some time in the game, this has to come a little bit quicker to you. Like
Square root of
now, it is the square root of 3. It's square root of 3 over 2 divided by half. Square root of 3 is not quite as big as the square root of 4. So it's not quite 2. Right? So if I'm here at pi over 3, I'm not quite at 2. And then if I'm back here, I should be symmetric like that. As I get closer to where the denominator is 0, these numbers are real small. These numbers are close to 1. Take a number close to 1 divided by a number that's a small, small, small fraction, and you get something that's big. So the graph over here, as I get closer to that asymptote, grows without bound, without hitting that line. And then it's going to do this down here. Between pi halves and pi, let's see, this is 1 pi over 4, 2 pi over 4. I'm at 3 pi over 4. Does anybody know the tangent of 3 pi over 4? It's -1, because the sine of 3 pi over 4 is a positive square root of 2 over 2. Cosine of 3 pi over 4 is a negative square root of 2 over 2. So at 3 pi over 4, the tangent is hitting -1. 3 pi over 4. That's 4 pi over 4. What about the tangent of 5 pi over 4? Just take a wild guess. That's going to be 1. So that same shape is going to repeat itself in here. And then again and again. This is considered one period of the tangent function. Between every odd multiple of pi over 2, you've got this graph that rises as you read from left to right, concave down till it hits the intercept, concave up beyond the intercept. So how long is one period? How long is the interval from minus pi over 2 to pi over 2? Pi. Tangent has a period of length pi. Tangent has a period of length pi. So if I stick a number here, then it's going to change pi by a factor of that number that I put here. So for instance, if I wanted to compare the graph of the tangent of x with the tangent of 2x, what happens? How does the graph of the tangent of 2x compare? What's the period now? Normally is pi, but I've changed it by a factor of 2. Right? Period, normally for the sine and cosine, we did 2 pi over b. Here b is 2, and the period is pi. So I would just relabel this. I would label that negative pi fourths, and I would label that positive pi fourths, and then change that to pi eighths and negative pi eighths. But it doesn't change the zeros. It just puts that at a new number. And changes the other ones as well, right? So tangent of 2x, I put this at pi over 4, negative pi over 4, and then draw my tangent graph. Okay? All right, now let's graph the cotangent function. Let's graph the cotangent. Let me rub all this off, put a cotangent in there. Cotangent is the ratio of cosine to sine. So this graph is going to have a bunch of asymptotes as well. The asymptotes for the cotangent graph occur where the sine is equal to 0. Where's the sine 0?
Pi, 2 pi.
Multiples of pi, right? So this graph has its vertical asymptotes. At each whole number multiple of pi, which means the domain of this function is x other than those values. It has the same range. It has a numerator that hovers between 1 and -1 and the denominator as well. So when this numerator is close to 1 and the denominator is close to 0, the values are really large. So the range of this trig function is also from -infinity to infinity. So the graph is going to look very similar, but different enough. So let's put our asymptotes in there. Let's see, your graphs go pi, 2 pi. I'm going to put the asymptotes in red because the line through the origin here is also an asymptote. Sine of 0 is 0. Where do you think the cotangent function crosses the x-axis over here? The value of x makes the cotangent 0. Well, they'll be the same ones in which the cosine is 0. They'll be smack dab in between that all the pi halves, right? So the intercepts are at the pi halves. So those are places that it's going to cross this x-axis. So now I want to know what happens at the pi over 4s.
1.
Let's see, this is 1 pi over 4. This is 3 pi over 4. What's the cotangent of pi over 4?
1.
For the same reason the tangent is 1. Sine and cosine are both positive, square root of 2 over 2. What about the cotangent of 3 pi over 4?
-1.
Because the sine is positive, but the cosine is negative, square root of 2 over 2. So in here, here's pi over 4. Cotangent takes on a value of 1. At 3 pi over 4, it takes on a value of -1. And then we said the closer we get to these places that make the denominator 0, the larger in magnitude the y values are. And every piece is going to look like that. Why would it change? And this then, right here between 0 and pi is 1 period. Only the tangent and the cotangent have a period that's pi and not 2 pi. The cosecant and the secant will both have periods of 2 pi. So that's a little spoiler alert. In order to graph the secant of x, I want you to draw one period of the cosine of x, 0 to 2 pi and negative 2 pi to 0. Get one period on each side. So get you a blank grid, draw a cosine curve through 2 periods. Draw the cosine curve between negative 2 pi and 0, and then the cosine curve between 0 and 2 pi. And then I can show you the secant curve. Secant was 1 over the cosine. That's why I said let's draw the cosine curve first. So I'm going to draw the cosine curve between 0 and 2 pi, and I'm going to draw that one in black, and then I'm going to draw the secant curve in red. This particular function is going to have some vertical asymptotes. Where are they going to be? Wherever the cosine is 0. Those were the odd multiples of pi halves. So let me get my cosine curve in here. Let's make this a 1 right here, and negative 1 there. So cosine crosses at the multiples of pi halves. It's a negative 1 here, crosses, it's a positive 1 there. And then we do it again back here, crosses, negative 1, crosses, positive 1. So that's the cosine of x in black. All those x-intercepts become asymptotes for the secant curve. Everywhere the cosine is 1 or negative 1, so is the secant. Because if you take 1 or negative 1 and divide it into 1, you still get 1 or negative 1. So the secant is going to pass through all of these points right here. The secant is the reciprocal of the cosine. So as cosine gets smaller, secant is going to get bigger. As these cosine values get smaller, secant gets bigger. For instance, right here at pi over 3, what is the cosine of pi over 3? Nope, the other one. Cosine of pi over 3 is a half, right? Cosine of pi over 3 is a half. Because pi over 3 is the same as 60 degrees. If cosine of pi over 3 is a half, the secant of pi over 3 is 1 over that. So it's going to be 2, right? So everywhere cosine gets small, secant gets large. Over here, it does that in the other direction. So it repeats these little parabolas over and over in between. And the cosine is going to hit all of its y values. Oh, let's see. Oh, I think I lied to you. Glasses. I lied to you. got one period marked. They mark one period from here to here. From 0 to 2 pi, using the fact that this would match up over here. But if you said your period was from here to here, I'd be happy with it as well. Either way, it has a period of length 2 pi. Got one bowl going up, one bowl going down. That consists of one period. The rest of the graph is that duplicated over and over. Okay? But one period has a length of 2 pi. So if you want to use this as the period, I'm happy with that as well. Just so that you see the parabola action happening. So we would say the domain of this thing, well, I can take the sine and cosine of every number except the odd multiples of pi over 2. So I'd have to say x cannot be the odd multiples of pi over 2. Now, how are you going to describe the range? How are those output values? What do they look like? Look at those red graphs. I'm not going to get any of these numbers.
It's like one.
I'm going to get numbers 1 or more, -1 or less. So you get values of the secant that are 1 or more or -1 or less. So if I just put the secant in absolute value bars and say that the absolute value of the secant is always bigger than 1. This says the same as saying that the secant of x is smaller than -1 or equal to, or the secant of x is greater than or equal to +1. There's no such thing as a secant taking on a value of 1/2 or 1/3 or 0 for that matter. It'll always take on values beyond 1 or -1. Cosecant is going to do almost the same thing, except for to graph the cosecant function, draw me the sine cycle from -2 pi to 2 pi, and we're going to make those parabolas on the bumps and the asymptotes at the intercepts. Yes, sir.
No.
Good? Okay, so let's get one more graph in here. Let's graph the cosecant function by doing the same thing.
Let's start off with sine.
So go in your last little grid there, draw a sine curve from -2 pi to 2 pi. Because the cosecant is the reciprocal of the sine. And this one's going to have all of the vertical asymptotes where the sine is 0. And that's going to be at all multiples of pi. Where the sine is 1, the cosecant is also 1. Where the sine is -1, the cosecant is -1. And then it does the reciprocal of the rest of the graph, so you're going to get those little bowls facing upward and downward from the humps of the sine curve. Again, I'm going to draw the sine curve in black and the cosecant curve in red. So those are going to be the intercepts of the sine curve. And the sine hits its 1s and -1s at the pi halves. Okay, so the sine curve is going to do this. And then here again. Now let's draw the asymptotes and the cosecant curve in red. So the asymptotes occur at all the zeros of the sine of x. And then the ones, the negative ones, will be on the cosecant, but opening away from the sine curve. So in the interval from 0 to 2 pi, you see both the upward and the downward portions of the cosecant. That's considered one period. Easy enough to remember? Let's explain all this thing. We've got the vertical asymptotes there, which states that the domain of this particular function means that x cannot be any multiple of pi. The range is the same as for the secant function. Numbers smaller than or equal to -1, greater than or equal to +1. So the quickest way to say that is that the cosecant of x in absolute value is greater than or equal to 1. And the period is 2 pi. So what do you think the equation would be if I take this axis here and put it here? Let me see if I can do that in another color. Make this the x-axis. So that's on there. So that this is 0, that's -1, that's -2. What have I done to the graph if I erase that axis and move it up to here?
Shift it up and down.
I shifted this graph down 1, didn't I? What would the equation of that shifted graph be?
Would be cosecant of x minus
The cosecant of x -1. Right? So depending on where that is, so we can do the same kind of shifts, up and down, left and right, with the same versions of the numbers. The only thing is with cotangent and tangent, your period is length pi. These all have period of 2 pi. So I'd be happy if you know the graphs of sine, cosine, tangent, and then can fake the other ones. All right? All right, thank you, guys.
Have a good weekend.
Thank you.
Oh, right on.